When we pass a current through a wire in a magnetic field, the wire feels a force. We can work out the direction based on Lemming's left-hand rule, which I'll come back to in a minute. But this concept is how electric motors work. Using a magnetic field and a current through a wire is how we produce motion in an electric motor. Let's have a look at how they work. So the setup looks like this. So we've got magnets on either side of the motor. We've got a north pole on the right-hand side and we've got a south pole on the left-hand side. So the magnetic field is going towards the left. In the middle of the motor, I have a loop of wire and we're going to pass a current through this loop like this. So as the current goes into the loop, it's moving away from you into the screen, and then on the other side of the loop, it's coming out of that wire again and towards you. So let's use our left-hand rule to figure out which way the loop is going to get pushed when we switch this circuit on. So first finger aligns with the field, that's going that way. Now the second finger is aligned with the current. We're going to look at the left-hand side of the loop first of all. So the current is going this way towards me, away from you. And that means that the thrust, the force, is going to be upwards on the left-hand side of the loop. I feel like I'm saying a tongue twister. So this side of the loop is going to get forced up. What about the other side of the loop? Well, the field is still going this way, but the current is coming towards you now. So I've got to have my hand like that. And that means that the force on the right-hand side of the wire is going to be down. So that means this loop is being rotated because the left-hand side is being pushed up, the right-hand side is being pushed down. So it's going to get all the way round to there. And then, well, it would stop because this can't get up anymore and this can't get down anymore. But what actually happens, if you look at the connection that we've got at the very bottom there, it's connected in a clever way. Once the loop gets to this sort of upright position, then the connections on the end of the loops swap over, which is going to reverse the current, which means now this bit of the loop is suddenly going to start getting pushed down and this bit of the loop will suddenly start getting pushed up. So it will continue to rotate until it gets all the way back round to here again, and then they'll swap again. That just means that the loop is continuously rotating in one direction. So that's the basics of how electric motors work. Now, I know it can be a bit tricky to wrap your head around how those bottom connections work. They're called split ring commutators. I'm trying my best to explain them. My animation abilities are a little bit limited still. I can do some 2D stuff, but I'm not very good at 3D animation. But fortunately, there are some other YouTube videos out there which animate it amazingly. And I think seeing really how it works in 3D can really help your brain understand what's going on. I'll link to some of my favorites in the description, but just Google split ring commutator, electric motor, stuff like that. There's some fantastic animations out there.